Hello, my name is Sarah Barnes, and I am a 7th grade math teacher at Allen Middle School in West Shore School District. I just finished up my first year of teaching. The last day for the kids was June 1st, and my last day was June 5th. So here's some reasons why I chose to go into STEM for this master's program. I have a personal interest in STEM subjects in the career paths. I was actually the only girl in my technology and manufacturing and woodworking classes in high school. I completed my undergraduate honors thesis on STEM and underrepresented middle level populations, where I examined the benefits that STEM education had on these students. And I just think the world in general is becoming more STEM centered, and just makes sense to teach our students in a STEM fashion and how to use these different, or work in these different fields, I should say. Some interesting facts about me. I enjoy spending time with my family. This right here is my 2-year-old sister Julia. This is my 19-year-old brother Nathan. Actually, he will be 20 on Saturday. That's me. And that's my other sister Noelle. She's 5. I'm getting married in October. This is a photo of myself and my fiance Kevin. We really like to travel together. We just got back from a trip from Portland, Oregon. I do like painting in my free time, the little free time that I have, what with teaching and planning a wedding and master's classes and whatnot. And of course, my favorite cartoon character is Jerry from Tom and Jerry. As for my definition of STEM, I think STEM is really so much more than just science, technology, engineering, and math. I think it's really just a style of learning and teaching. It was tough for me to come up with my own definition that wasn't just the definition I used for my honors thesis, so that is actually what I used. I think STEM education is an approach in which the 4 STEM subjects are integrated through an instructional method that uses design-based problem-solving, discovery, and exploratory learning strategies. I just think this is a really great definition. It really explains all of the pieces of STEM and STEM education. As for parts of the Vasquez text that really explain STEM education, here's one of the quotes that I pulled out. It's an interdisciplinary approach to learning that removes the traditional barriers separating the 4 disciplines of science, technology, engineering, and mathematics, and integrates them into real-world, rigorous, and relevant learning experiences for students. That term interdisciplinary, I think, is really important. It's not, they're not separate things. They're not really discrete disciplines. It brings it all together. STEM education is not fundamentally different from other teaching and learning, except that we're asking students to make additional connections not only between the STEM subjects, but also with other knowledge, ideas, and concerns that they bring into the classroom. Again, that connection between disciplines, I think that that's the main part that I want to highlight right there. STEM in itself is not a curriculum, but a way of organizing and delivering instruction, and that's kind of what I said on the previous slide. And finally, the real power in STEM teaching comes from the connections among the fields and how they support and strengthen each other. As for how I can incorporate STEM into my 7th grade mathematics classroom, the one thing that I thought of mainly was this year in my 7th grade algebra class, I had them complete a water park project. They did this in place of a test on linear equations, systems of linear equations, and there was a little bit of data analysis involved since I had them make a scatter plot and determine its correlation. The project was broken up into 8 tasks. They had to draw out the water park on a graph, label the entrance points, draw the lines between the points, find the slope of the lines, write equations in slope-intercept form, translate those equations into point-slope form, add some new attractions, that's the scatter plot part, and then determine the correlation. They had to identify intersections and then solve systems of equations, and then they also had to write a reflection. I did include a little project extension with my students. They could either decide to create a 3D working model of one of their attractions, or they can make a digital model of the entire water park. And here's a picture of one of my students' blueprints for her water park. So you can see the different attractions that she has there. She's got like a swirly looking slide, a lazy river, help center, some things like that. One of my students made one of his water slides, and he had a pump and running water, and it was really cool. And then another one of my students made his park on Minecraft, and I didn't really give him any direction. I just said, hey, make the whole park digitally, and this is what he came up with. So here's some screenshots of that. As you can see, he has a little security desk there. Those are some other attractions. And that's his main water slide. You can see the steps and everything going up. As for evaluating this project with the different STEM strategies, I thought this would be a little more STEM aligned than it actually is. This strategy right here, my students determined the best way to organize the water park. That was the make sense of problems and persevere in solving them. Using the appropriate tools strategically, they used calculators, rulers, colored pencils, things like that. Attending to precision with the graphing, reasoning abstractly and quantitatively. That's when they were finding the equations of the lines. Over here, learning how to use new technologies as they become available. That was the project extension with the Minecraft and everything, trying to figure out which technology to use. And then analyzing and interpreting data. That I figured was the part where they had to make the scatter plot and determine its correlation. And down here, constructing viable arguments and critiquing the reasoning of others. That was really their reflection. And then the whole project, they had to look for and express regularity and repeated reasoning, trying to figure out if what they were doing made sense. You know, if they had something with a negative slope and they ended up with an equation with a positive slope, they had to really think about if what they were doing made sense. There are a lot of reasons why I think that STEM education is important. Some things that I pulled out from the 6 chapters and then the first video is that STEM education makes learning relevant to students. It helps them understand why they're learning, what they're learning, why it's necessary. Here's one quote from the text that I pulled out. I also think we need to teach new generations to become STEM literate, and this is the definition for STEM literacy from the text. From the first video, I pulled out that the STEM disciplines are vital for a thriving economy and a safe and healthy society. From the second video, this video was just so quotable, so you'll have to excuse all of my quotes that I have here. Neil really talked about the importance of understanding science, technology, engineering, and mathematics and appreciating it, and how important it is to the economy. I love this quote right here. I think I'm going to print it out and make it a poster in my classroom for whenever my students ask why they're learning what they're learning. Here he talks about how science and math helps you become a good problem solver. And again here, why STEM is necessary for the financial stability of our economy. And again, just another quote about how important STEM is to our future society and economy. As for my goals for this course, I want to determine best practices for incorporating STEM strategies into my everyday mathematics education, and also discover STEM-related projects to use in my math classes next year. You know, I did do the water park project this year, but I know that there's so much more that I can do with all of my classes, not just my algebra class. I want to learn more about integrating science and not just engineering, technology, and mathematics together. I feel like I'm lacking in the science department. I also want to learn how to explain the importance of STEM education to my students and their parents, and examine any relationships between STEM education and project-based learning, since I did just join the project-based learning team at my district this year.